Well, g'day, Max there again. Welcome back to the shop. So, trapezoidal threads, we're still playing around with that. So last video we made up the tooling to cut this plug gauge, which is a TR28 x 5 trapezoidal thread, 28 being 28 millimeters outside diameter. It's a left-hand thread, 5 millimeter pitch. So what we need to make is a boring bar to cut an internal trapezoidal thread, and it's for part of this item here, which is off our Casto power hacksaw that we are currently rebuilding. So I have a piece of bronze to make the nut out of when we make our final part, but 50 millimeter bronze is like $1 a millimeter. It's not cheap stuff, so you don't want to go screwing it up. So hence, once we've made our boring bar, we'll find a piece of material, a piece of scrap, anything, and we'll do a test cut with it to make sure it's cutting okay, and that will allow us to determine some dimensions to cut the thing to prior to the last bit of final test fitting on our real part. And it will also ensure that our tools are ground somewhere close to their correct size. So it's just a test piece. So don't see many trapezoidal threads being cut on YouTube. I don't recall any. So let's crack on. So we'll head over to the Bridgeport first and get this boring tool knocked out. As far as the tool bit, we ground the tool bit when I ground the outside diameter tool bit for cutting this, and that same tool we may or may not use in our proper shaft. We do have to screw cut a long shaft. I may use the 3-tool method for that. I'm not sure yet. I'll wait till we go to do it. So yeah, boring bar made, tool bit silver soldered in, and some test cuts. So let's crack on. So yes, if you're unfamiliar, unsure, trapezoidal thread is the metric version of an Acme thread. So it has a 30-degree included thread angle, as opposed, what's Acme? I think it's 29 degrees or something like that. So yeah, just the metric version. Unfortunately, dimensional information regarding the pitch diameter is not sort of something that's readily available, especially regarding what constant to use when you do your measurement over wires, the calculation there. So there's a bit of missing info, like compared to an Acme thread where all the information is out there everywhere. So let's move on. So I'd like to machine a bit of a registration flat on the underside of our threading bar here. Just to make it easier, when we put it in the lathe, it sits flat and our tool is going to be located on the correct angle, which is horizontal. And just eyeballing it from the piece of tool steel to the jaws on the vise, we're pretty good there. Okay, that should satisfy our needs, so I'll rotate it round and do the same thing on the clamping side. So I think now we can calculate how far our tool needs to stick out, chop it to length, and get it silver soldered in position. It actually sits that way around, so it's on centre. So I've just put our bar back in the milling machine and put this dual angled feature on the top. Now that's just not there to look cool, like a set of double overhead foxtails. It reduces the mass, so when we silver solder, we don't have to put as much temperature in this end part, hopefully. And we've crisscrossed the areas on our tool just to give the silver solder somewhere to key into, so it's not on a nice smooth ground surface, just for that bit of extra strength. So we'll head over now and get that in there. So we've cleaned out our soldering area with some isopropyl alcohol. Get that way over there. We're going to be using Easy Flow flux paste and Pro Silver 45T silver solder. So we've pre-fluxed our soldering area, and we've also checked the stick out on our tool to make sure we have enough sticking out. We'll get a bit of heat in the bottom. That's it, I think we're there. I'll dab a bit in this end there just to make sure. Okay, we'll let that be. So I've mounted up our tool, we're on centre, we've indicated the bar and square, therefore giving us the best chance of our tool angles being what they're supposed to be. I've got this old cheapo, it's a little diamond lap, and I just give the tool a bit of a clean up after the silver soldering just to get all that black crusty stuff off it. And I've got a piece of acetal-like substance here in the chuck, and we're going to use this to take our test cuts, try out our new tool and establish some dimensions so we don't blow our expensive bronze part when we go to do it. So we have our bore on the minimum size for this thread, so I just want to run the boring bar in and get a mark with a texter on the bar so I know when to turn the machine off. So if I reverse the lathe and get the bar in, we are engaged on our half nuts on number 1 on the threading dial. That will stay engaged, I will not be disengaging them. And let's get this mark established first. It's just a mark so I know the tool is clear of the end of the bar when we take our proceeding, take our cuts. Okay, I'm just going to run the bar back out. I have my cross slide dial there marked in a safe position, so when we poke our bar back in the bore we're not going to crash. So after we take our cut, we wind the cross slide in, and that's the only position that I can go, as this bar has no clearance on it at all. So our cutting will start, we've touched the bar off at 0 there, and we continue around until the 5.2 mark there. That will be our maximum depth. So we're going to plunge the tool in. Hang on, I'll get you a better camera angle. We will be using straight in feed on the cross slide. We'll cut to full depth. We'll have a test fit, and if it's tight, which I'm expecting that I think it will be, what we do then is I'll set a dial indicator up on the compound slide, and we'll start backing the compound slide out that way and trimming off the leading edge of the thread. So we're just going to be cutting just on this rear face of the tool here only to trim the width of the thread to the required size. So I didn't do a video of grinding the profiles on this tool bit, but I did it when we ground the tool bit for the external trapezoidal thread in the previous video, as I still had all the angles set from that one there, so it was just as easy to do this one here at the same time. Okay, I'll just run a trial cut through, cutting nothing, and make sure this camera is not going to hit the tool post. Okay, focus gets a bit blurry there, I'll make an adjustment. Okay, let's crack on. There'll be a minor delay in between each cut as I mark the cross slide dial with a texter here to mark our position. We'll keep it to a minimal, so let's get the tool back in. Okay, we'll put on a cut. This is 0.5 millimeters off the diameter. Lovely. Not sure where the remnants went. Here they are. Back to our retract position on the carriage, on the cross slide. Put the tool back in. Another 1/2 millimetre cut. That's 1/2 millimetre off the diameter. Retract the tool. Going to reduce our cuts now to 1/4 millimetre cuts off the diameter, and it'll be that way for here on in. And this is a left-hand thread that we are cutting, in case you're wondering why we're going out instead of in. Defluff. We're a little bit over halfway. As you can see, yeah, there's not much clearance on that bar at all. We're right there, you know. It's looking good in there, but hard to see as everything's white. Snow blinded. Okay, I'm going to take a spring cut next. So same setting as what we did that last one. Only getting a bit of a wispy fluff. Reminds me back at high school days, we used to have a teacher we used to call Wispy. Coming up, should be one more cut after this and then a spring cut. Okay, this will put us at depth. Get this shit out of there. Okay, we'll do a spring cut till our tool comes out without any fluff on it. Well, you know what I mean. No, this one, the last one. Oh, it's still a bit fluffy. We'll go one more, just for good measure. That's what we want to see. Okay, let's do a trial cut. I am expecting to have to sidestep the tool, but we're not sure how much. Get my fat hand out of the way. Let me take my jumper off. Oh, sorry, my jacket off. That's right. She's going, but we got no clearance. We'll have to take a little bit more, but that's a good sign. So what we take off now, we're going to be sidestepping. So I'll just get our tool back in the correct position so we can safely enter the hole. I think we're about good there. Touch more. Okay, let's get a dial indicator set up on our compound slide. We'll zero that out there. This is the big advantage when you're screw cutting of having your compound slide in line with the bed on your lathe. So now position like now it's easy for us to adjust the width of our thread. If your compound slide is angled and you're coming at it at an angle, it makes it very difficult. You've sort of got to, you lose all your positions. You've got to back your cross slide back in. You've got to back your compound off and then come back in on your cross slide and re-pick up to get another shift in position. So that's why I normally screw cut this way. Very rarely I'll use the angle compound method, but it always, yeah, I don't like doing it that way. So let's bring you in. And likewise, if you have to pull a tool out for an adjustment or sharpen or breaks mid-cut, you know, this method here, it's really easy to get back on track again with your thread rather than dick around. Okay, we'll just go 05-ish. Locking my compound. I always lock my compound slide when screw cutting. Okay, we'll take a trial cut. So this is going to take a wispy little amount off the flank of the thread, the leading edge. Then we'll have another test fit. Okay, I'm just going to run the tool all the way back until I get clear. Going in, we need to take just as much again. No clearance on that at all. I'd say we'll probably end up having to go an extra 0.1 of a millimetre. We've gone 0.05. Let's get the tool up a bit closer again. Yeah, we'll get it all the way in. Okay, so we're going to wind the cross slide back out towards me to our cut depth. Then I'll make an adjustment on the compound. So I think we'll go just there. It's about a 0.1 millimetre shift in total off the leading edge of the thread after this cut. Okay, we're all ready. We're at our cut depth on the cross slide, so let's send it. That was a little bit that came out, so let's have a test fit. If I can get it in the bloody hole. There we go. That's exactly where we need to be. We've got no end play at all. Let me zoom you in. So we've got minimal side play, nothing whatsoever. Okay, so that's a good test. So when we cut our real part, we know exactly the dimensions that we need to land on now. It's only a 0.1 side shift, so what that means is our tool grinding came up pretty darn good. There is one more test we need to do. We'll take it out, and this other test will ensure that our screw cutting tool is actually square. If it's not square, this will not screw in this way, being how neat we were the other way. Absolutely perfect. Yeah, if you cut a thread and you get a beautiful fit with no play one way, and you screw your nut on from the other way and it's tight or it doesn't fit, it's because let's disengage this. It's because your tool is probably not square to the job. I learnt that one there when I was a young bloke. I think I was about 15 or 16 where I cut a 1-inch British Standard Whitworth nut and bolt, and that happened to me. That was before my apprenticeship, and that's where I learnt. Okay, cool. So I've noted down all of our necessary information. We bored this to 23 millimeters inside diameter, 5.2 millimeters in feed, 0.1 millimeters side shift for our thread, which is trapezoidal TR28 times 5, which is 28 millimeters OD, 5 millimeter pitch. I plugged in my optical comparator. Now, I've had this thing kicking around the workshop for a short amount of time, and I don't even know if the thing works. It's a really old one, and I have to make up a bit of equipment for the staging area where you put your part, and give the machine a good clean down and find out why the vertical axis doesn't go up and down as it should. So I thought, let's put our plug gauge that we screw cut the other day with our trapezoidal thread, and we'll have a bit of a look-see. So I just got it propped up somewhat in a propped up fashion just there on the staging table. It's enough for me to see if this machine's going to work or not, or if it's scrap. Like, it needs a really good clean and make everything fully serviceable. But you can clearly see, you know, when I've radiused the threads with the file on the edges of the crest there, how much it actually takes off. And we can actually get a measurement of our root width. So I've just, for now, zeroed out a dial indicator. Just sat on the end of the table like that because the micrometer spindle up here for adjusting it, it all needs cleaning up, and the machine needs moving so I can access everything. But for now, you know, we can get a bit of an indication on the width of our root. So the dial indicator zeroed, I've zeroed it out there. We can move across to its approximate area on the other end of the root. Just using these lines on the screen, and we're coming up 150. We're coming up 1.8. Yeah, right there is 1.8 millimeters. We're supposed to be 1.83. So we're about 1/1000th of an inch too skinny on our root width. To measure the crest, well, we can't now because we've gone and radiused the edges. But what we can do is check the thread angle. So if I align the cursor up, or that line, that diagonal line on the screen up with the edge of our thread, Bit tricky. Well, I suppose it's easy when you learn how to drive them. Okay, we've got an alignment there anyway, so let's look at the reading. So we're coming up about 73 degrees, 2 degrees shy of where we should be. I'd actually put that down to probably a bit of play in my lathe as the loading comes up on the tool, because we ground those angles pretty accurately in the tool and cutter grinder. Was accurate as we were able to. So let's check the other side of the thread. I'll scoot over. It's just this fine line that we're lining up. So that's pretty close there, pretty good there. So we'll see what the vernier scale is reading. So we're pretty close to our 75 degree mark there. It's only a hair off it. So that's good. Yeah, so this will be a really useful bit of gear to have around the shop. It's an old Jones and Lamson. I don't know what year it was made or how old it is. You know, could be 1960s, 1970s, I've got no idea. But unfortunately it takes up a lot of room and I think the new ones are far more compact in size. But yeah, I'll get it cleaned up, make sure everything's functional, and I think we might have something useful. This is the first time I've had it powered up and I wasn't even sure if the light was going to go or things like that. It's got other magnification settings, but I don't know if it's all working. It sounds like the lenses are working, but yeah. I go, so that's 20 times, that previous one was 10. This is 31 point something, and see, you can't read it. So go back to where we were. But of course, to get angles accurate, you'd have to have whatever fixturing you've got that's holding your part. So we'll be a little bit off here with this thing here, but I just put that there to see if the thing's going to actually work, because if you're off here you're going to be off on your readings here, so you'd need your fixturing calibrated level with the screen there anyway. Just a small point. Well, okay, that all went rather well. Things don't always go that smoothly with this style of profile thread. You just got to be really careful on your major and minor diameters, because when you're doing your final test fits, if things aren't fitting properly, you know, you start scratching your head, oh shit, is it binding on the minor diameter or is it binding on the flanks? And it all went well. So hopefully we have the same successful outcome when we go to do the bronze nut in our part for our Casto Power hacksaw. Anyway, hopefully you got something out of this, and hopefully you'll watch the video where we do the trapezoidal threading on the proper parts. The previous video, yeah, we made up the threading tool for the plug gauge I have here. That's the one we ground over in the tool and cutter grinder. So anyway, cheers, thanks for watching, and hopefully see you in the next video.